So I was already taught that if you have a quadratic in the form of x squared plus bx plus c equals 0, where b and c can be any numbers, that you just find two numbers that multiply to make c and add to make b, and we'll call those numbers p and q for this demonstration. Then we can factorize it into x plus p and x plus q. Once again, these will be actual numbers. For example, it might be x plus 2 and x plus 3, which you would get from x squared plus 5x plus 6. So one of the brackets is 0 because the two of them multiply to make 0. This means x must be either minus p or minus q, as only those would make a bracket equal to 0. However, when it's in the form ax squared plus bx plus c equals 0, and a is not equal to 1, for example, that'd be a 2x squared, or a negative x squared, or a 3x squared, we have to do something different. The usual way to solve this is to find two numbers, p and q again, that multiply to make the same as a times c, and add to make b, which is kind of the same thing we did earlier, because a was 1 anyway, so it was just the same thing as multiplying to make c. It's just extended here as a times c. Then you have to split the middle, which basically means taking the term that has the x in it and splitting it into px plus qx. So whatever the two numbers are, now you can just factorize each half separately. This always works very nicely because the inside bracket on each side after factorizing is the exact same, like in this case here. And we just merge them together, and that's the factorization, which you can then solve. This is called the AC method. However, I thought of something else. What if we turn ax squared plus bx plus c equals 0 into x squared plus b over a x plus c over a equals 0, basically dividing everything by a. And 0 divided by anything equals 0, so the quadratic is still intact. Then we can just find two numbers, p and q, that multiply to make c over a and add to make b over a. Because there's only one x squared, so we can just use the same method from the beginning and it still works in the same way. But this is not very nice because these numbers are fractions and it's just kind of hard to work with. To combat that though, if p times q equals c over a, p and q being the numbers in the brackets, then the two numbers ap times aq would equal ac. Because if you're multiplying both terms by a, you're multiplying it by a, which gets rid of the denominator, and then you're multiplying it by a again, which is ac. And those numbers will also be so that ap plus aq equals b, because you multiply the whole thing by a, and b over a multiplied by a is just b. So now, all that's needed to solve it is to find two numbers multiplying to make AC and adding to make B, exactly like that step in the AC method, and those numbers are AQ and AP, so to get P and Q, just divide them both by A and put them into brackets, and solve normally. However, I today realized that even though you can divide everything by A when you're solving, that those brackets work when they're equal to 0 and you're finding a solution, but the factorization we did just now is not the correct factorization, because if you just see ax squared plus bx plus c, it could be anything, so dividing it by a will change it unless it is equal to 0, which should never be assumed if it doesn't even say. So that means the factorization, since we divided it by a at the start to make the x squared term just 1x squared, we need to multiply it back on now. Luckily, in the class context, these questions would usually, if you use this my discovered method, although it was previously discovered as well, cancel out nicely. For example, if you get x plus 2 over 6 times x plus 3 over 6, you had to divide by 6 to get those fractions, because a was 6. multiplying everything by 6, and the times 6 can be distributed among the two brackets and then just multiply it, and it's just 3x plus 1 times 2x plus 1. But yeah, that's what I discovered. Very quick for solving, but remember to multiply back by a once for factorizing. It's ax plus p times ax plus q divided by a is another way to do it. Distribute the divided by a in the most appropriate way to cancel out as nicely as possible that you can see a way to, because in these questions they will always just simplify nicely.